All right, well, I'll go ahead and get started with the introduction. So first of all, thank you so much to SAP for hosting us again. And thanks to all of you for joining us at the Unstructured Data Meetup. My name is Chris, and I work at this company called Zillis that you can see on this slide. And we are the maintainers of an open source project called Milvus, which is a vector database. Who has been to an unstructured data meetup before? I know a couple of faces, but we still have a lot of new people. This is really great. So you may or may not be aware of Milvus. It's an open source vector database. And I encourage you guys to take a look at it. We do have 3 versions. We have a light embedded version, so it's really quick to get started, throw it into a notebook. And then we also have a standalone version and a fully distributed version as well. But that being said, we wanted to make sure that we built this meetup so that we can build community, and we don't want to just talk about Milvus, because as much as I love talking about Milvus, I think you guys will get really bored if all we did was talk about Milvus. So that's why we came up with this concept of a meetup called Unstructured Data, and it's really about building out community in this era of GenAI. And GenAI is really exciting. Everyone's talking about it. Every company now has like AI in the title. And when we think about GenAI, we actually think about it in these 3 pillars. Naturally, you have to have the hardware, right? And everybody knows the current darling of NVIDIA driving lots and lots of hardware. But really, the reason the need for so much hardware and such powerful hardware is because of the models, right? These foundation models are giant. They need a lot of computation. And guess what else they need? They need a lot of data. And under the data realm, of course, is where we sit as a vector database. But I'm here to hopefully inspire you to consider that there's actually a lot of tools and a lot of products and projects that are still needed to support the data side of these pillars, right? When you think about traditional databases, for years and years and years, we've built and used and relied on various tools that help you to create ETLs, pipelines. You want to be able to pre-process your data. Maybe you want to enrich your data, put it into a database. You're going to maybe want to do something with that database, maybe visualize it, have different views of it. And then, of course, that really scary security team comes in, or the governance team comes in, right? We got to make sure not everyone has access. Well, guess what? All that needs to happen in the world of unstructured data. And some of these things have not been built yet. So we're hoping that by having you guys come to these meetups, listen to the different speakers, some of our speakers are actually starting to fill the gap with some of these capabilities, but maybe it's something that you'll be like, hey, I want to do that as well. Or maybe you might want to join one of these companies that's going to be speaking. And we've actually we've connected a number of people with various companies, either founders or employees. So there's a lot of great networking that's to be had at these events. So if you are hiring or looking for a co-founder, at the end of the meetup, I'll give you an opportunity to make that announcement. And also, if you do want to speak at any of these events, let myself or Frank or Sachi know. And always happy to accommodate. Just to give you guys a little story about how this happens, at our second unstructured data meetup, our first one was a disaster, by the way. We had like all of 5 people. But our friend Yi here, he actually was one of the speakers at that second one, and he's actually going to be speaking next month. And Sri, who's sitting up front, who's one of our speakers, he's from Intuit, and he just came up to me last month and say, hey, we're working on an open source project. I think it would make sense for us to talk. So we really want to encourage everybody, not only just build those projects, let's help you to also get community involved so we can make those projects really successful. I mean, if you think about open source, that's what it's all about, right? It's about building upon the trust and the help of the community to make these projects really strong. So yeah, San Francisco is also a location, but I think a lot of you guys are pretty happy that we're doing it down here. So we'll continue to do it down here. Go South Bay, right? And And if you give us a star on our GitHub repo, Sachi's actually going to do a little raffle for some swag. Of course, everyone loves swag. Okay, let's bring our first speaker up here. Okay, so I talked a little bit about, what the community looks like for unstructured data. And our first speaker is from 12 Labs. And what he's going to focus on is, of course, on the model side of things. But what is more exciting, come up here, James, you can grab a chair and a mic, is that if you were at the last meetup, we had Frank talking about multimodal and actually the kind of the history of how things came to be with transformers and how you can do, text and images. Well, guess what? James is going to take it up a notch and talk about video search, which I think is really, really exciting. So with that, James, you ready to go?
Yep, I think I'm ready to go. Thanks everyone for making it today. Big fan of Zealous and their work around community building. I've been to several of the session up in San Francisco and always enjoy different speakers, different talks. So yeah, I very glad to have the chance to speak in person today. I also know the Zealous team very well. Since last year, I've been engaging with them in multiple occasions. So I think this is great that we actually got a chance to feature a real life, product integration together. So the title of my talk is Advanced Video Search, leveraging TwelveLabs and Milvus for semantic retrieval. So for those of you who are not familiar with TwelveLabs, this is our company mission. So we believe that video most closely resemble the sensory inputs from the real world. So as a company, we sit at the foundation model layer and we build the type of multimodal foundation model, that model video, and then pushing the boundary video understanding that can model the world. So just a quick recap on video understanding for those of you coming more from text or image background. So what is video understanding? So this is a very quick slide talking about the historical, evolution of the field. So video was first invented back in the late 19th century, and back then, to consume this medium, you have to manually watch them, right? And then, try to understand what's going on in the frame. When speech-to-text model was first commercialized in the late 20th century, now you can build this type of solution that can generate, speech, basically transcript right from the video to decipher what's going on in that video. However, the transcript can sometimes very difficult to comprehend, and they sometimes disconnect from the visual information of the video. And since Sonnet by Jan LeCun in late 20th century to the early days of computer vision with AlexNet, MobileNet, etc., we've been building those type of models that is specialized on very specific tasks to generate metadata or text from the video. The issue here is these metadata or text can very shallow, and they sometimes cannot capture the full meaning or context of the video, and they can create huge discrepancy when you try to consume it. So this is a hypothesis and what I see in terms of research direction for video understanding. So in the past, we built specialized model to solve low-level video persistent tasks. Think about detecting objects, tracking objects, recognize action in the video, instant segmentation, etc. At the moment, with the focus on foundation models, we now can build model to tackle higher level of video understanding tasks. What I mean by higher level is things like retrieval, classification, question answering, capturing the type of tasks that require a broader understanding of the video. And I think in the future, everything go much into multimodal. We can be a single model that can do general purpose video understanding. So this diagram kind of cover the end-to-end stack of what video foundation models look like and how does that impact the the application layer, right? So video foundation models sit at the bottom, and then they generate these multimodal embeddings, which can then be wrapped as API, different type of API for different tasks. And these tasks can then be, sub-consumed by video-centric application. And this application can range from a variety of different industry domains, right? And I list out a couple here, from advertising to education to sports, creator economy, but any industry that requires working with a lot of video data, I think that could be relevant. And then the end user, consumer, enterprise, they could be the type of folks that consume the data, the intelligence from video-centric application. And yeah, they probably gonna demand this application to be intelligent from the get-go, right? Yeah, so that's a couple of slides talking about video understanding for folks who are not so familiar with the field. Okay, so I want to double down on this concept of video foundation models. So you you found a Zealous and Milvus, you probably already know a lot about embeddings, but I just want to give a very high-level description a bit, right? So you're familiar with like unimodal embeddings, right? Text, image, audio. These are like single modalities that represent like that specific modalities, right? However, I want to focus on the concept of video embeddings, which is basically the multimodal combination of all of these three modalities. Because you would think about video, right? You have the visual information, you get the audio, conversation, speech in the video, and you also have text in the video itself. So in order to like create like high quality video embeddings, you actually need to combine like all those three modalities together, right? So yeah, this is a slide from a blog post I wrote last year. But basically, the multimodal evolution of vector embeddings can be contributed to, like, number one is the rise of multimedia content, and number two is the versatility of the transformer architecture. So the combination of those allow us to be like video transformer that can take a single video and then generate video embeddings that is contextual representation of the video itself. So our focus at TwelveLabs is to build this type of video foundation model. Earlier this year, we released this state-of-the-art video foundation models for any-to-any retrieval called Marengo 2.6. This is an architecture diagram of the model, and if you're interested in how it works, you can take a look at the blog post. But at high level, it includes like three separate key components. We have a visual expert module that capture all the appearance, motion, and temporal changes within the video. Then we have an audio expert component that capture all the auditory information, meaning like verbal conversation as well as non-verbal audio signal related to the video. And then we have a get fusion module that assess the contribution of each of this expert and then merge them into a unified multimodal representation for any-to-any retrieval. And the blog post have a little more details on the quantitative and qualitative benchmark of the model. So if you're interested in that, you can take a look. So this is from a research point of view. So you might be wondering, what are the downstream tasks that this model can enable, right? So semantic search is definitely like the first one that we're very familiar with, right? So imagine that you can find like any scenes in a corpus of video using natural language query, right? So we do offer a search API that do it end-to-end, in which you can just like upload your corpus of video, type in a search query, like for example like basketball slam dunks, and return all the video segment that correspond to that search query, right? So that's one very straightforward task. The other one is the classify API that does zero-shot video classification. So traditionally for classification, you have to come up with a predefined categories of like what classes that you want to put the data on, right? So with zero-shot, you can actually come up with that classes on the fly, and then call our API to like classify the videos into that prompt right away. And I think most relevant to this audience is the embed API that we currently still in private beta, but we just released like 2 months ago. But so for example, like with search API, we do end-to-end, right? But since this is a very developer-focused audience, maybe you want to do that on your own. You want to work directly with the embeddings layer to like store them in your own choice of storage, adding metadata, perform more interesting arithmetic math on those vector embeddings. So we released this embed API that essentially taking video as an input and generate like multimodal both video level and clip level embeddings. Video level means that generate a single embeddings for the entire video, and clip level embeddings mean that like let's say it's a 20 seconds video, and you can break it down into like 4 chunks of 5 seconds, and then get embeddings for each of those chunks. So this is pretty cool because you can enable a very downstream task ranging from sentiment analysis, clustering, anomaly detection, as well as interesting RAG workflow, right, which I'm going to talk about in the next couple of slides. And before showing like a quick example how the code looks like, I just want to give a high-level slide talking about the research horizon at TwelveLabs. I do mention this Marengo model. We actually also have another model called Pegasus, which is a video LLM that can generate summaries, chapter highlights from the video itself. So as a company, we focus both on the embedding-based tasks of search, classify, clustering, as well as the generative-based tasks, right? Things like video question answering, video chapterization, video chatbot, etc. Yep. So yeah, the reason I got it, invited to this talk is basically talk about like our recent collaboration with Milvus. So we released a blog post like 2 weeks ago. We've been working with the team at Zealous, namely Zhang and I think Xiaozhen, software engineer and head of ecosystem partnership, to demonstrate like an example of how a 12Labs embed PI and the Milvus can look like. So if you're interested, you can go take a look at this blog post that go in the high level details how it looks like. But at a high level, what happened is it use our embed API to show the embeddings from a video and then store them into Milvus. And from there, you can do things like retrieval and more sophisticated tasks. So I do have a notebook to showcase how it looks like. I already run it this morning, so it's gonna show the output results. This is an example of how it looks like. You set up installation, just pip install the SDK, the PyMilvus client library, do some simple setup with Milvus. Okay, so this step right here, first step, you want to connect to Milvus. So this is basically you import the Milvus client and then you initialize the clients, right? So this code is this part right here. And then you want to create a Milvus collection, which is like Milvus way of a table to store the video embeddings and associate metadata. So this is how it looks like. So I initialize a collection names called 12Labs underscore demo underscore collection, and then I use the .create collection from the Milvus client to create it. So you can see here that the collection has been created successfully, right? Okay, so the next step is, well, I talk about the code real quick, but this next slide, I talk about the next 3 steps of the workflow. You generate the embeddings, and then you insert the embeddings into Milvus, and then you perform similarity search. So in order to generate the embeddings, you use our embed API. So you get our API key, and this is the function that I use to generate the embedding. So I initialize the 12Labs client, and then just write a function here, taking the video URL, create an embedding task. I try to monitor the task and then retrieve the results, right? So this is the function. So I put in the video URL of this very simple stock video, which it's a 15 seconds stock video. I got it online. It's like a 15 seconds Chromecast, commercial. Yeah. Okay, great. So I put in video URL and then in general embeddings, and I call it. So this is the output. It creates a task, it process the video, and then it generates 3 embeddings from the video. So the first one corresponds to the first 6 seconds, the second one corresponds to the next 6 seconds, and the last one is the last 2 seconds. And you can actually customize the embeddings how long you want it to be. So yeah, so now you got your embedding essentially. Okay, so for the next step, you want to insert embeddings into Milvus. So I wrote this function to insert embeddings into Milvus collection. I basically create an array that include the video ID, the vector from the embeddings, the start and end time and the video URL, and then I insert it into Milvus. So you can see here, I insert 3 embeddings into Milvus. And by the way, like the syntax, I follow directly like, in the Milvus docs, and it's like super simple to work with. So I think the DevX of like, the open source database, like really good. And then now you can perform similarity search, right? So for this function, I use the dot search function within the Milvus client. And to do that, so here are some of the key value. So collection name, the query vector, the limit of how many results you want to return, and the output fields, right? So that this function performance called similarity search did that. It then returned a list of the search results where each is a dictionary containing the match entities, metadata, and similarity score. So okay, so in order to perform that search, you need a query vector, which is the input query to put on the similarity search, right? So in the example, I tried both ways. So I tried both the video-based search and the text-based search. So in this example, my query vector is essentially the first embedding from the output from previous one. So like the first 6 seconds of the video, and then I call the perform similarity search, right? And so you can see it returned the 3 output. The first one obviously is 1.0 exact similarity score because it's the same embeddings, right? And then you got the other 2 right here. And the text-based search here is leverage the embedding back from TwelveLabs to generate text embeddings from a text query. So so I define this function get text embeddings, and then I come up with this text query, a woman with a blonde hair, and then the query vector, I call that function to generate, text embeddings for that query, and then I, call the similarity search again. So these are the output. So this is text-based search, and this is, a video-based search. So think about like, basically there are 2 ways you can like, perform search, right? You can type in the query you want to work for, or you can like input like a video segment and you can return like the video that semantically similar to that input. So it's super powerful for like recommendation, right? Things about like your input video and then the output is going to be all the video that visually is similar to that input, right? Yeah, this notebook is available on the blog post that, all the way down here. So if you're interested, you can like replicate that notebook and bring it on to your own workflow. A couple of things about, go back to slide. I want to finish my talk with a couple of like important like developer resources for folks who want to try out TwelveLabs. So this is high-level diagram explaining the end-to-end, platform, what we do. So I talk about search, classify, generate, and basically, it make it very simple for you to just upload your video, call an API, and get an output. We also have both JavaScript and Python SDK just to make it more convenient for people who want to build application on top of our API in a common programming language. Most recently, we released a pretty interesting project called Jockey, which is our collaboration with the LangChain team. It's an open source project that let me pull up the repo. It's an open source conversational video agent that pull up like our API, LangGraph agent frameworks, and then other sort of LLMs to allows you to basically do conversation with the video. So this open source. So if you interested in like working with agent and with video, so I think this is a great opportunity to like, just contribute and like be on top of it, right? Because I think this combined both of all the exciting stuff going on in the field, right? Agentic workflow and multimodality. Yeah, and then finally, we have a Discord channel for our users, community members who want to, try our product, and so yeah, this is a QR code for people to join and check it out. Yeah, so that's the end of my talk. If you want to follow up and learn more about our work at TwelveLabs, this is my email. Yeah, welcome any question.
Cool, thank you so much. That's pretty exciting. Foundation models that are now helping us to find similar videos with video. I mean, we're not using text. I mean, although you can, that's pretty rad. I can't imagine what you guys are going to build with that in a few months. So questions?
So I have a couple of questions. First question is, so it is once. Oh, okay. Is it better? Yeah. Okay. Uh, First question is, you have 1024 dimensions, right? And
Yeah, 1024. That's right.
1024, right? Uh, so what's the size of a single vector? That multiplied by 4 bytes, would that be a single vector?
Mhm. Yep.
And I think your total number of vectors getting generated is also dependent on how big the video is, right?
That is correct. So by default, right now by default, every 6-second clip is one embeddings.
Right.
Yep.
So what I want to understand is that what's the max size of vectors and like data that you are pumping in this database? Like what have you tested with?
Yeah, that's a good question. I think 1024 is like the max dimension size we have right now. Yeah, I mean, it's still a private beta product, so we probably need more testing. I think we try with like 30 minutes. We got requests for like 2 hours, but I think like right now it can work with up to like 30 minutes.
Okay. Okay.
Yeah.
Thank you.
Yeah, but obviously, as it got more developed, we can. I think like one of the biggest challenge in terms of like working with longer video is going to take a very long time to generate embeddings because of the processing, on the back end. Yeah.
Okay. Thank you.
Any other questions? Oh, okay. Yes. Sorry. No worries.
Is it on? So I've seen multimodal search before where they actually split the query into text and
Mhm.
audio and video, and this is bringing it all together.
Yeah.
How good is the text going to a video embed?
How do you do like how
So
can you define goodness?
so what I understood is it's taking the video, which is audio and everything, and it's putting it in the vector space. And tell me if I'm talking crazy, but it's taking a vector space. Then it takes a text, embeds that, and that's actually doing just as good a job of finding that video versus some other text in the
Yeah,
vector store.
it's pretty good. I mean,
Yeah.
it's a qualitative assessment, right? Right now we only offer generating text embeddings and the video embeddings, but we also going to have support for image embeddings and audio embeddings, meaning that you can do image to video search and audio to video search.
Cool.
Yeah, so yeah, I think for now we're still testing it, and it's more about like what are the use cases that you can dream up in terms of quantitative performance. Like we have a blog post that talking about I think go pretty deep into the model performance. This one right here, it like showcase all the retrieval results. We got text to video, text to image, text to audio, etc. So you want to like go deep into like the metrics and like the caudities. I recommend taking a look at this longer, more like research focused purpose.
Cool.
Yep.
That inspired a related question. So, I've been familiar with applications that did on a very large scale doing OCR on text seen from videos. So how well do the models work on mapping to text that appears in the videos?
Yes, I think we did a really good job. That's just we actually offer that capabilities on our playground as well. Like, so for example, this is our playground environment. It's more designed for, the non-technical audience. So I can show you an example of how OCR search look like. So let's just say we have a spot video. So I choose search, and we have an option called text and video and logo. So this is a like very simple example, but like I type in the query Olympics and it returns all the video segment that, there's the word Olympics in it, or at least the logo Olympics.
Well, actually, I was thinking about you had some examples there that had some like a leaderboard and some others that had some signs. So I was talking about the text in the signs on the video.
Yeah, I mean, so it depends on, so you have to try it out, right? You have to upload that video and
All right,
test it out.
thanks. I'll
I
check
think
it
that's the
out.
best way to handle it. Yeah.
Any
Yeah.
other questions?
I think there's one more here.
So I had a question regarding like how long does it take to generate the embeddings for a single video, like given a certain length, like few minutes, let's say, like is this approach feasible in an online setting or typically all workflows are offline setting, just generate
Yeah, so
embeddings?
so right now it's more feasible for the batch approach, offline setting. So like for that 15 seconds video that I showed in the demo, it's probably take like 30 seconds to get out embeddings. I mean, we always going to try to optimize it to be faster. I mean, this is still a private beta product, right? So in the future, yeah, we definitely like hope to bring it to real time and online processing. Yeah, but we got a lot of that request for that. So I think that also like depends on, like I say, if Milvus supports like real time, retrieval, something like that, real time indexing. On the database side, that could make like our job as a foundation model provider to be like even easier. Yeah.
All right, here we go.
I just run it on my like Collab, the default free version. Yeah.
All right, any other questions? Cool, one more round of applause for a really cool talk, really cool technology. Bill, you want to head up there? All right, we're gonna switch modes a little bit. So we talked a little bit about a pretty cool foundational model, and Bill, who works at Zillis with me, is now going to put it in action. Not that actual model, but he's going to talk about Agentic RAG. Are you ready?
Yep. Okay, everybody hear me? Good. I think this one is more clear than the microphone, is it? Okay, so. Okay. So today we're gonna share with you how to build the agentic RAGs using the Claude 3.5 model, LlamaIndex, and also Zillis. So Zillis, as you know, we have the Milvus as our open source project, and also we have the Claude. So you can use, you can use one of those. So let's see how the whole system, the computer system, like anything related to the ML system evolving. So the whole large language model system started in like 2022, and then until last year, the end of last year, and also the beginning of this year, we see there's Chat GPT, right, which makes a large language model even more popular. So, but if you look at the diagram on the right bottom, so that's the very basic large language model system, right? So you're gonna query from the system, and the large language model will based on your prompt to generate the answers for you. That's very simple. And then, however, it's as you may already try to like ChatGPT, right? So for example, you want to see like how you're gonna spend your vacations for the coming independent day, right? For example, you have a week, so you throw this to the ChatGPT. ChatGPT will give you an answer which is not related to your circumstances at all, right? Because ChatGPT doesn't know when you're gonna have the break, right? For example, because the independent day only have 1 day off, right? You can take 3 days for vacation. However, you want to spend the whole week. How can the ChatGPT know, right? Then there comes another thing called compound AI system. So the compound AI system is a little bit more customized. So so you still send some prompt to the large language model. So the LLM gonna take your prompt and generate a search query, and this search query gonna search into the DB as you see on the right side. So that DB stores all the information about yourself. And then based on that information, large language model will generate a more customized results for you. So that's another like more evolved model system. It's called compound AI system. So RAG, as everyone may already know, so RAG is just another it's one of the kind of the compound AI system. And then later we have another one called as you can see there, called agents. So as you can see, our system shifts from models to the compound systems. So what are the limitations of the models, as you can see in the bottom left, right? It has very limited data about yourself, and it's very hard to adapt. So what is the benefit of the compound system? As you can see, it's very modular, right? Like RAG, it's like a DAG. You can put it together and connect different pieces together to generate a new RAG for yourself. And it's very easy to adapt to your own circumstances. And you can see the diagram there. In the compound system, there is a term called control logic. So as you can see, the control logic for a compound system can be very programmatic, and it can be very autonomy. So as you can see, if it's programmatic, which means it's more like robust. However, it's very fast, right? It's very specific. So if you search a RAG gonna give you it's gonna give you the answer very fast. However, if it's gonna be a large language model, the response will be much slower. Okay, now let's talk about what is large language model. Large language model agents here. So I have a link here. This link is from Lillian from OpenAI. So in the beginning of this year, she concluded what is agent. So basically, agent has those functions in the diagram. Agent, it can do the reasoning, and it can act based on your request. So action also, it can act via tools. A tool can be like a search pipeline, like a calculation, and also you can ask it to do coding, and also you can act via we are calling another large language model. And the third feature for the agent is that it can access to the logs cache, right? And also definitely it can do the planning. It's like chain of thoughts, right? So now, as you can see with the agents, our previous system becomes even more complicated. Now you input the query, right? And then it can think, it can plan, it can plan accordingly. And it can gonna react via the tools based on your request, right? And you're gonna have an answer. However, it will not respond to you directly. It's gonna observe to see, it's gonna evaluate, right? And then if it's not good, it's gonna go back to you to ask you to put even more query in, right? And then then eventually, give you the final results. So now we talk about the agents, because today's topic we're gonna talk agentic RAG, right? Now let me remind everybody here, and I'm not sure if you know or not, what is RAG is, right? RAG is retrieval augmented generation. And you can basically, it's very simple. It's have a doc, right? It has a data ingestion part and also the data query part. For the ingestion part, it's gonna trunk the docs into different pieces and parts, right? It's gonna put it into a vector database like us, all right? And then when you do query, just query the vectors, a DB, right? And query those different trunks. And it can give you and you feed that into the large language model. It's then give you the results. So that's what a RAG is. However, there are a number of weaknesses of a RAG, because certain questions where the top K retrieval may fail, right? First is the summarized questions. For example, if you ask a RAG to summarize a document for you, it cannot, if you didn't train it for that purpose. And another one is comparison question. So for example, we feed the information into the system and ask the RAG to compare the performance of employee A and employee B. It couldn't. And another thing it may fail is the structured analytics and the semantic search. For example, we asked the RAG to analyze the risk factor of the highest performing vector database companies in the world. It may not work, or it cannot give you the very good results. And the fourth failure it may have is for a very general multi-parts question. For example, we ask the RAG to tell me A, and then I ask him it to tell me B, and I wanted to make a table and summarize it for me. Then it's gonna fail. So how can we help with it, right? Then we can use this agentic RAG. So as you can see, what is so with a query, RAG, and also response, it's a very original RAG system, right? But we can have agents in the beginning and have agents in the end of the RAG, right? And also we can have another agents to call the RAG. So basically here, RAG becomes a tool for the agent. Okay, so now let's talk about the agents. So from the very simple agents to very complicated advanced agents, right? From phase 1 to phase 0, or no, phase X, right? So there are 5 types of agents right now. I'm gonna share with you. So here on this page, there are only 3. The first one is a very simple one. It's called a routing agent. Basically, it's very simple. It's like you send a query to the system, and with a set of choices, and then the system gonna give you the output of the subsets of the choices that you previously sent to. So that's a routing. Basically, it's a very simple chatbot, right? And the second one is query planning. Basically, it's gonna break down the query into multiple sub queries, and each query gonna run a RAG, and in the end, you can ask a RAG to combine the results together and send back to you. And then another type of agents is the tool use, right? So you can have agents you can use agents each to call a LLM, and each LM to call a API for you, right? So that's how we use that. And however, right, for the previous 3 types of agents, there's something wrong if you spot it. First is that it cannot solve the problem of the sequential multi-part problem. Another is it's not stateful, right? So if you're dealing with the microsystems and work on the scalable, like large scalable system, right? That's the major problems here. We need to make a system, try to make it stateful, to make it, and then we can make it perform well, right? So then it comes to the React. So React agents is basically it's reasoning plus acting with the large language models. Here you can see there is a diagram, which is, I took it from the paper that I have a link there called React Agent Model. So basically, as you can see, it's basically a loop of thing, right? So you send a query to the large language model to do the reasoning, and it give you the results based on the environment you see, and then you can use that result to trace back and do the reasoning again, and you can do it in a loop. So that's basically the model is. There are a number of companies that already developed. Like they have the codes which implement this model. So there is one from Cohere, another one from OpenAI. However, even the React cannot solve one thing. So firstly that it cannot plan. So it has to run step by step, right? It cannot plan ahead. And another thing is that because it's a loop, right? It cannot run like parallelly, right? Then there is another agent that can solve this problem called dynamic query planning. So basically, this is a diagram, and there is an implementation called LLM Compiler, which can solve this problem. Basically, it's you have the input, you put it into a planner. The planner you can think about it, it's gonna launch. It's a DAG. It's gonna launch a bunch of brokers, and each broker they're gonna so that's gonna run a large language model. As you can see, if you're interested, you can take a look at it. However, even with all of those, there are still a lot of things we didn't solve today. For example, we don't know what's happening inside of the large language model agents, right? And how can we control the internal steps, and how can we make the agents very customized, right? Right now, for each vertical problem, we need to build an agent for it, right? I know a lot of startups, they are building these platforms so that based on the user's request, they can launch different agents to solve that very specific problem, right? But it's still like everybody's just working on it. We didn't see a very solid solution. And next, so as everybody already know, what is agent is and what is agentic RAG, right? And how can we implement one? So this is a demo that I did, which is a very simple one. Basically, what it does is that it loads a list of Airbnb home listing, right? And we load this one. We download it from the Hugging from the Hugging Face, and we load this data into the Milvus vector database, and then we use LlamaIndex to launch Agentic RAG. And we even use it to create an agentic RAG. And then we ask the model to tell me the best listing in New York, and then it's gonna give me the results. So basically, because we run it, I will just show the code here. First step, we just do the data. We load the data. We download it from the Hugging Face. And then we're gonna create the embedding of it based on we use a embedding model from OpenAI to do that. And next, so in that phase we generate the text embedding, and then you just register a vector database no matter which one you choose, and ingest the data in it, and then you use the LlamaIndex to write a query engine tool, and then create an agent, right? And bring everything together. It's like this. You have the data loading, and you have an embedding model, and you embed the text, which is Airbnb listing, and put it into the vector database. And you use LlamaIndex to build the retrieval tool, and also use it to generate an agent layer to create an agentic RAG. And also you embed it with the Claude 3.5 at the large language model capability, and then you're gonna have a final result. So let me see. I have a final result to share with you. Oops. Yeah, that's fine. Yeah, I think I don't find how to get back to my browser, but I will share the code with you. I will send it to Chris, and she's gonna share it with everybody. And this is my LinkedIn. Feel free to scan the code, and if you have any question and interested to talk to us, feel free to text me.
Excellent. Thank you so much, Bill. All right. Any questions?
Hello. So the question here.
Oh, hi.
Yeah. So the question is similar to the previous one. But it has much more broader scope in the sense that what's the amount of data that you see that your customers are pumping in database like this vector DB?
In vector database, the maximum right now we see like we have different cases, right? As you see, we have open source, we have the cloud Claude Zealous, right? The maximum data load into our system right now we say is around 10 billion of vectors. So it's
10 million vectors.
10 billion
10 billion.
vectors.
Okay.
10 billion, yeah.
And that would account to how much TB it would be in terms of terabyte, right? Not more than that.
Yeah, it's definitely going to be more than that. Because the input is going to be images or like videos, right? You need to run the embedding model, right? And convert it into the vectors. Then the result is going to be 10 billion vectors. So think about it more. It's going to be like terabytes. Yeah.
And in terms of loading, what's one parameter that you as database builder is trying to optimize on? Like, are you optimizing for throughput, latency, what?
We have a bunch of enhancement. For example, indexing, right? We need to index it when you load the data into vector database. The speed of the indexing should be super fast, right? And also when you query it, we need to give you the correct answer. The top K results should be correct, right? So definitely the QPS and also data latency is some of the asks from our customers. And they are very, very strict. Even for some of the financial complaints, yeah, that's very strict.
And what patterns have you observed? Like, is bulk loading very common, or like people stream and load it and then they change the fields also, or how is it? Like, how in terms of operational, what are the frequent operations that you see?
So I would say both are very frequent. The bulk insert, right? A bunch of the batch processing is definitely one of the use cases. And another one is the streaming one. As you see, for example, some of our customers are like chatbot company like ChatGPT, right? So think about that. If you launch a chat with a ChatGPT, right, it's gonna create an entry into the vector database. And once you like keep chatting with it, it's gonna keep modify the data, like the information you store in the vector database, right? And that's gonna become a streaming mode. Yeah. So we support both. And both are very, very frequent. Yeah.
Thank you.
Mm-hmm.
So I think you asked some really great questions. I do want to add that it's also very use case dependent. So if you're going to be doing something like anomaly detection or drug discovery, then you might want to have recall be, one, right? That's going to be more important. Whereas maybe if you're building a recommender system, maybe QPS is more important. And so, it's important that whatever vector database you use has the ability to tune to fit with your use case. And then also when you talked about, the size, it's not just about the number of vectors, but also the dimensions that you have, right, for each of the vectors. So there's a lot of things that, kind of fit into the answer for the questions that you had. And then I think as far as like what changes, once again, that's use case dependent, but no matter what, everybody knows no matter what kind of database, change happens a ton, which means your index is changing, right? So once you go into production with any vector database, you need to put that into consideration, right? Because it works on my laptop is not going to work in production, right? We know that. We've all, been through that. So yeah, and if you want to know more details, Frank is one of our solution architects. He has a lot of experience with putting this into production. Okay, sorry about that. Any other questions?
Hi. So can we encrypt the vectors and do search and
Encrypt it,
yeah.
right? Yeah, this brings to our another one. So I think another thing, you are more concerned about the data security, right? So which means because for us, we have the open source. Zealous is more like a SaaS product, which means we have the control plane and also data plane hosted by us, right? But for you, if you're concerned about data security, we have another mode called bring your own cloud, which is that we separate the control plane and also the data plane. So all the data stored in your own environment. Once you send it in, you can encrypt it. Once you query it, you can decrypt it. You can do the BYOK, right? Bring your own key, which you manage all the keys. So you have the full control of your own of your own data.
But you cannot do like search just based on encrypted vectors itself.
Well, search based on the encrypted vector. Right now, we didn't see. So it depends on what's the use case. But we didn't encounter this before. But we would happy to talk. Yeah, if you have such thing. Yeah. Hi. I'm sorry. Well, so basically you run encryption algorithm, right? Because vector is just it's like binaries, right? So then you crypt it into another thing and store it. Yeah, because eventually you're gonna store in the file system. For us, it's gonna be AWS. If it's AWS, it's gonna be S3. Because once you search, you need to somehow decrypt it and then query it back. Yeah, definitely performance will be a problem, right? So that's a thing. Yeah, we see a lot of customers, they're considering it because data security is definitely a very important thing. Yeah, but definitely considering about performance, they may need to wait. Yeah, to use the vector encryption, which brings us back to our BYOC, so that you can have all the data in your own VPC, in your own cluster, right? So there is no concern on that part.
So I understand. Sorry, a little bit. I just want to kind of get. You can encrypt it, but the other things of cosine similarity and all those things kind of go out of the door. I'm having a tough time understanding what an encrypted vector means.
So everything is, because when you search it back, you need to decrypt it, right? So you have a.
So I can maybe shed a little bit of light on there, and I'll be very quick. The reason why you typically don't see encryption in vector databases is because it will change the nearest neighbor distance computation between the vectors. So you'd have to have a way to either decrypt it in memory, or you'd have to have some sort of encryption algorithm that takes nearest neighbor computation into account. It doesn't change the distance either if you're using L2 or if you're using cosine similarity between the vectors. And that sort of defeats the purpose, right? Because we have vectors, we don't know what they mean anyway. We just know that they're a list of numbers, right? We don't really know what they mean. The computer knows what they mean, but we don't. Yeah, we can chat about this more after. We got one more question here.
So you built the Agentic RAG. How reliable was that? Did you run it like 20 times and see it come back and answer every time?
It depends on the how many times you run it. It's gonna evolving by itself as well. So what I see is that every time right now the answer is different, but there's definitely a way we can enhance it. Yeah.
Thanks.
Still early days. All right. Thank you so much, Bill. Let's give Bill a round of applause. And then let's bring our friends, Derek and Sri from Intuit. And we're going to go to the other end, back to Pipeline. So we're going to talk a little bit about streaming.
Perfect. I hope everyone can hear me. Sounds good. So, hi everyone, I'm Sri. I work as a product manager at Intuit, and I have Derek, who's joining me today. He's a principal engineer on the Intuit platform team. So today we are going to talk about inference on streaming data. On a very high level, the agenda is just we're going to share a little bit about what does our platform team do at Intuit, what does streaming data mean, what are the barriers for doing stream processing. We'll discuss a lot about in the context of inference on streaming data, and we're going to share about how are we solving some of the pain points and the problems using our open source project called as NumaFlow. And we'll do a quick demo of the platform and how we are actually using it within Intuit and also externally within the community. So a quick high-level overview of what Intuit. Probably majority of you might be aware of Intuit as a company. We are a global fintech platform which offers different products like QuickBooks, TurboTax, Credit Karma, and then MailChimp. And these are the most important platforms at Intuit, and you can see some of the numbers at the kind of scale that we operate at, right from machine learning infrastructure to the kind of services and the kind of transactions that we process on a yearly basis or a day-to-day basis. We are very big on open source. We consume a lot of open source products out there, and at the same time, we also contribute a lot back to the open source. For example, like we are actually the team that is behind Argo. If anyone is operating in the Kubernetes ecosystem, they would have been aware of like Argo CD for deployments, Argo workflows for running your ML workloads, and all of that. And we are going to share about another project called as NumaFlow today. But yeah, we are a huge consumer of open source, and we also open source quite a lot back to the community. So diving into today's topic, primarily around streaming data. Like, what do I mean by streaming data? So you can think of streaming data as continuous stream of events flowing in from different sources. It could be like your IoT sensors, it could be your social media feed, or it could be from like financial transactions, your shopping orders across the board. So when you have different kinds of sources, like how do you connect to these sources and do real-time processing? And that so that you can generate probably analytics, or probably you would want to do inference or any of those pieces on a very high level. That's all about like a quick introduction about streaming data. But streaming data is pretty much everywhere. Like these are the various examples that you could see on a day-to-day basis where you think about IoT data or like shopping orders, hotel reservations, or the flight bookings, and any of those. And even observability needs, like let's say where you want to understand like how your systems are performing real time and all of that. So streaming is pretty much everywhere. And one of the most prominent use cases, like if you think of in the context of ML, is that, hey, it's not just about data processing. Probably you would also want to act upon the events and do some kind of inference as they are flowing in. So that is like one of the most common use cases that you would see in production on a day-to-day basis. So when we are trying to think about stream processing, especially in the context of Intuit, or even generally out there, there are a couple of pieces that come into the picture. Let's say, for example, you as an engineer or a ML engineer or a data engineer who is actually interested in consuming these events on a day-to-day basis. Let's say, for example, you are getting all of your IoT data through a Kafka topic, or maybe your shopping orders through a Kafka topic. You want to process all of those events real time. But one of the biggest pain points as an engineer or ML engineer is you didn't want to focus on connecting to these event streams. Rather, you would want to focus on actually processing the data, or focusing on your business logic or processing logic in itself. So that is the most important pain point, like where developers were actually writing a lot of boilerplate code in order to connect to any of these event streams. Like most commonly at Intuit, we use Kafka as one event stream, like Pulsar, SQS, SNS, and different kinds of event streams as such. That's one pain point. But the second pain point is that if you think about the real-time analytics or the data processing kind of use cases, are there platforms out there which actually do it? Yes, there are a lot of platforms out there. Let's say, for example, Apache Flink. But when you think about in the context of Apache Flink, these are data engineering frameworks which are very much oriented towards data engineers, and they're probably like kind of a Java shop. But if you're an ML engineer or probably a developer who is interested in Python or Go, if you want to do real-time stream processing, you'll not be able to do it because the frameworks are not really mature. The learning curve is really high. So how do we bring the, how do we solve for these pain points of ML engineers or other developers who are interested in real-time processing for different use cases, like processing, data processing, or even inference, or any of those?
is one of the biggest challenges that we had. And the third pain point is primarily for ML engineers, where they wanted to easily be able to consume these events, try and test out multiple models like in an A/B testing fashion. So the existing frameworks were not scalable, not extensible, and all of that. And lastly, and most importantly, if anyone is actually working on the platform teams or you write services on a day-to-day basis, the biggest challenge with scaling any of your models, which are primarily event consumers, is the biggest pain point, because if you deploy it on Kubernetes, ideally you would want to use metrics like resource utilization, like maybe CPU utilization or memory utilization in order to scale off your services. But that doesn't work well for event consumers. Ideally, you would want to scale based upon the event throughput that you're receiving from your upstream. And then also you want to scale based upon your downstream dependencies. Let's say you are writing your results to maybe like a database or anywhere, you would want to scale accordingly end to end. So packaging all of these different pain points, right from developers to ML engineers to data engineers, like we worked upon a platform called as NumoFlow. It's an open source project. We'll share a quick link for that. So let's dive deeper into what NumoFlow is. So NumoFlow is basically a Kubernetes native platform for doing event processing at scale, or you can develop any kind of event-driven applications. When we say Kubernetes native, we use a lot of Kubernetes constructs in order to do the data movement and all of that as a platform. But at the same time, we also focus on delivering all of these streaming semantics that are required for doing real-time analytics. Let's say, for example, you are interested in doing aggregations or maybe some kind of like streaming map reduce kind of functions. You should be able to do that using with the platform, but it should be very lightweight. So we provide it's a completely language agnostic framework where you can use any SDK that you would like right from Java, Python, Go, and even Rust if anyone is interested in order to do the stream processing or doing event processing at real time. And the third piece is we mentioned about scaling, right? Ideally, whenever there is a burst of events, you would want to scale automatically and then go back to zero when there is no burst of an event. So all of these have to be taken care by the platform. So we provide like scalable and cost efficient scaling out of the box. And one of the things that I would like to highlight is that the platform in itself is very lightweight, such that you can actually deploy it on edge devices as well. So we'll share some of those examples where folks from the community have actually deployed it on edge devices, and then they are doing some kind of radio signal processing and all of those. So now, on a very high level, like what are the various use cases where you could actually use NumoFlow as a platform? As like first, most importantly, like streaming analytics. Anyone who is interested in doing real-time analytics, like pre-processing of the data before doing inference and all of that, you should be able to do it. And the second is like the real-time inference use cases that you would have on a day-to-day basis. And at the same time, people have been using it for ingestion as well, where you have a stream of events that are coming in, and you would want to ingest into your vector databases or any of those, you should be able to do it with any kind of processing that you would want to do beforehand, before ingestion. And then lastly, people have been using for simple event-driven applications. When I say event-driven applications, just react to the events that are coming in. You just want to either ingest into DB or just act on those events that are flowing in. So these are like broad set of use cases you can use NumoFlow for. But on a very high level, if you can look at all of these pieces, it's not just a platform for developers or data engineers, for ML engineers. It's a general purpose platform that anyone can use for different kind of use cases wherever you have the needs for. So let's dive into a simple example of what does it actually take you to build a NumoFlow pipeline, and what do I mean by a NumoFlow pipeline? So I'm just going to take an example of doing a sentiment analysis on like a stream of events that you are receiving. In the age of like where everyone is thinking about LLMs, I'm just picking up a simple example of sentiment analysis. So the first thing is like we discussed, hey, as an ML engineer or like a developer, I don't want to really focus on what kind of event sources that I need to consume from. So let's say, for example, in this one, I just have a stream where is a source. I'm just receiving all of the events. For example, in this context, maybe a Twitter event or a feed or whatever it may be, where you want to do sentiment analysis. The second thing that you want to do is like inference. I got an event, I just want to do an inference on that. And lastly, you would want to write your results to some database or maybe Kafka topic or whatever you are interested in. So on a very high level, if you look at it, you're just trying to decouple your source to your sync and you're focusing on your inference logic. So out of the box, as a platform, we provide you sources and sinks where you can connect to different kind of event sources like HTTP, Kafka, like anything that you're interested in. There are a lot of open source connectors that you can use. But if you have really custom sources that you would want to write for, you should be able to do it as well, because we provide the flexibility of using all of our SDKs to write any of the sources. And the last one, I just want to, in this example, I'm just going to use a Hugging Face model because it's easily available and I can do inference on the stream of events that are coming in. Now, I just want to pass it on to Derek so that he can do a quick demo. We'll be doing multiple demos so that you can see the complexity of the kind of pipelines that you can actually create using the NUMA flow. So Derek, go ahead.
Thank you, Sri. So next, I'm going to give a couple of demos to showcase how to use NumaFlow to do sentiment analysis, to do inference on streaming data. So all the demos I'm going to do will be in using the UI provided by NumaFlow out of the box. Let me quit that. Let me switch to the UI here. So this is the UI provided by NumaFlow. You actually can do a lot of operations on the UI. You can manage your pipelines. In NumaFlow, we name each of the data processing jobs as a pipeline. So you can manage your pipelines. You can pause or resume the pipeline. You can create a pipeline or delete pipeline. So if you want to create a pipeline data processing job in NumaFlow, you can just click the button. You can give the pipeline stack here and then do a submit, right? So for example, I do a submit here. It's creating a simple pipeline. But for today's demo, I already create those pipelines before I can to save the time to for model downloading and the image downloading, right? So I already create those pipelines here. So first thing I'm gonna go is the sentiment analysis, as Sri mentioned. So if I click the icon and go into the pipeline view, and you're seeing the graph is actually the pipeline topology. So each box on this graph you're seeing is called a vertex. A vertex is nothing but a set of paths, which is used to run your data processing logic. And we auto scale based on traffic and load for for your pipeline, and auto scale each of vertex. And you're seeing the number here, which actually represents the number of paths you're running for this particular vertex here. And you also can see some other information. For example, you can see throughput and a watermark, all this kind of streaming data processing standard terms here. And now this pipeline has no traffic, so throughput is 0, right? So if you look into this pipelines for this sentiment analysis pipeline, I have 3 vertices here, as Sri mentioned in previous slides. I have an in. I'm using building HTTP source that can post some data to this pipeline for demo, right? And then I have a second vertex. It's called UDF vertex. UDF stands for user-defined function, where you can run your own data processing logic. Here for this sentiment analysis, I actually give an image here, but within the image, I'm running some code to call Hugging Face model to do a sentiment analysis. And then I have a third vertex here, which is a log sync, which also come from NumaFlow automatically, that you can just output your your upstream data into the log sync for it's like for testing purpose. All right, so now let me just switch to my terminal. I'm gonna send some data to this pipeline. I think I already created some text for demo. So for example, I'm sorry, let me reshare. Okay, I think you can see my terminal here. So the first message I'm gonna send to this pipeline is like this: the Meetup is very successful, right? So I'm gonna do that, and then switch back to this pipeline view. If I click this icon here, we're going to the vertex view, and we're gonna see things like a CPU memory usage. Everything is on this page, and you also can see the pod logs for this vertex. And then we're seeing the sentiment analysis for this Meetup is very successful, and seeing the sentiment analysis result is a positive. So if I send another one, let's say it's very cold today. And now if we switch back, and we're seeing immediately it's very cold today, and the result is a negative. So this is a quite straightforward sentiment analysis pipeline using NumFlow. And let's get back to the slide to see what we need to do to get this sentiment analysis pipeline running. And if you look at this page, on the right side, it's a pipeline spec, this sentiment analysis pipeline spec. So NumFlow is a Kubernetes native project. So we use the Kubernetes CRD to represent the data person job. So for a data person job, we name pipeline. There's a spec under this pipeline, and there are two major sections for this pipeline spec. The first section is called vertices, which is used to define the data processing steps. Here for this sentiment analysis pipeline, we have an in, which is an ADP source, and we have a UDF, it's a sentiment analysis. We're giving a container image. And we also have a log sync, which is used to output the result. And then we have a second section called edge, which is used to define the relationship between those vertices. So with this kind of spec, you actually define very complex graph for your data processing pipelines, right? And if you look at this left side, it's a source code. That's for this sentiment analysis. This is everything we need to have to get this sentiment analysis pipeline running. If you look at the source code, here the source code is written in Python, where there's a handler function, and then for this function signature, there's a datum, right? It's the argument. And within the function implementation, you're getting some binary from the datum, and then you're expected to be a string, and you convert it to string, and then you do a separate check. If the string is empty, you're going to drop it. And what you do next, you're actually calling a Hugging-based model to do a sentiment analysis, and you output the result to a JSON string, and you have two fields in the JSON string. One is text, original string, and the other one is sentiment, right? And they return the message. So if you look at this code, you cannot find anything related to, for example, the HTTP source and log sync. Everything you need to do is take care of a message. You just expect the message to be exist in your function, and the platform will make sure all the messages coming from a source will be delivered to you. And after you process a message, you return a message, and the platform makes sure all the message you return will be forwarded to your downstream. Could be another UDF or could be some other things. Right? So this is everything you need to have to run this sentiment analysis pipeline. So this pipeline is quite simple, quite straightforward, but think about it. You can easily switch the source from HTTP to something like a Kafka that really doing some streaming data processing. And you can switch the sync to some other thing, like it's another Kafka topic, and then you can get a real streaming data inference pipeline without making any code change, right? So I think that's the first demo I have. And if we continue, I'm gonna have a second demo, which is text summarization. The difference from this demo is like, so first demo, we have a quite straightforward line shaped pipeline to doing a sentiment analysis. And now for a second demo, I'm gonna have like some parallel inference. And let's directly go to the UI here. So I also created those pipelines beforehand. So if I click the inference pipeline, that's the second demo I have. Similarly, I have a HTTP source. I'm gonna post data to this pipeline. And then I'm gonna have 3 different models to do summarization for the message coming from the source. And here I can click the icon here and show you that actually I'm using the same image, same source code for all the 3 models. I'm just using an environment variable to say, hey, it's like a BART model, and then second one I think is like a Pexas, and third one is a LED. All the model, I randomly pick the 3 models from Hugging Face. So, and I'm expecting, I'm gonna send one message and then do 3 different inference summarization and send the 3 data to the log sync, right? So if I switch to the terminal, already everything running, and the data I'm gonna send for this pipeline is, let me show you. So the data I'm going to summarize is actually just a copy from internet. Right? It's Team USA, the basketball team, I just won the gold medal from in Paris. So I'm just got some information from internet to describe that, and I'm going to send this data to this pipeline. All right, so I'm making curl and post the data. And now if I come back to the UI, I click the sync. We are seeing there are 3 line of logs is 24, 23. So yeah, that's in 3 summarized result from the pipeline. So if I search model here, this one is from Texas, and this from BART, and this one I think is from LED. So we're getting 3 different summarized messages for one message from one input message. Right? So it's a very typical use case for A/B testing. You can easily, add any kind of models branch to your pipeline without interacting or without making any change to the existing data processing logic. Let's say your inference logic. Okay, so this is my second demo. If we could come back to the slides. So we just saw 2 demos, with a line-shaped pipeline and a tree-shaped, like to multiple branches. And actually, we can do much more than that. The first picture here shows the multi-source example for NumberFlow pipelines. Let's say you have some data in Kafka, you also have data in some other source, like HTTP or parser, right? And you're gonna have the same data processing logic, you're doing this inference logic for those data. And you don't want to create multiple pipelines to do it. What I'm gonna do is like multi-source within one pipeline, right? And you also can write the data to multiple different sinks. And the second one shows the joining example, which means you can do fork and join for your data processing logic. Actually, the second demo I just did is like it's a diamond shape. You like fork the pipeline into 3 different branches and then join on the sink. Right? You can join on any vertex. And you also can do some crazy stuff with NumberFlow pipeline. You can do cycle. You can send the message back to some vertex in front of you. It's very useful when you want to do some sort of reprocessing when some sort of conditions are met, right? And last graph shows side input support. If you're familiar with the stream data processing from familiar things like Apache Beam, you know what is side input, which is used to propagate some sort of configuration to every of your processing unit without interrupting your data processing jobs. So this kind of stuff also supporting NumberFlow. The last thing I want to show is a real production pipeline running into it. Yeah, refresh the page, right? So this is a anomaly detection pipeline running into production. It's a very complex pipeline, actually, if you look at the graph. And I'm going to skip the detailed logic, but anyway, there's a source which used to ingest data from a Kafka topic. And you're seeing, where you just keep some configuration for a Kafka, brokers and consumer group and topic name. You actually see there's some live information. Let's say, well, that's a TPS right now. I think it's 500 or something per second. And this pipeline actually send, get the data from Kafka topic, and then we'll do some live inference. If the model is not there or the model is out of date, they're gonna send to a training step. It's a trainer, and if the model is there, do inference and get the anomaly score, and then do some post processing, and then send to multiple downstreams. So one of them is gonna send to a waveform for metrics purpose, and the other one is like sent to another Kafka topic for some analytical purpose. So this is it's just a real pipeline running into it. And there's one thing I want to mention is like, so NumberFlow is a language agnostic platform. You actually can use whatever language you want to use to write your data processing logic. Let's say for this pipeline, for the training, from the trainer and the inference, you actually can, I think it's written in Python, right? And then let's say for this waveform sync, if you look at the image here, it's reading in Go, right? You can use whatever language you want to use to write your data processing logic. And the other thing is like, for things like inference and training, you probably need to run on GPU. But for the rest of them, post-processing, pre-processing, or any feature engineering, you don't need to run those kind of stuff on GPU, right? You just run it on regular resources. And this is the job with NumberFlow pipeline. So you can use your resources. You can have a better usage on your resources. Okay, so I think that's all I have. I'm going to hand it back to Sri to talk about the community engagement for NemaFlow.
So quickly to summarize, like some of the pain points we have discussed earlier, right? Like for ML engineers or data engineers, we wanted to solve the pain points of one, like removing the problems of connecting to any event sources. So if you look at this pipeline where you can see that you have Kafka sources available or any sinks that you would want to write the data to, they are already out of the box. And this is a pipeline where it's where multiple teams came together. Let's say, for example, you have data engineers who are more focused on pre-processing the data. And then let's say you have ML engineers who are more focused on serving your models. And then you have your typical developers who want to do some kind of event processing. So all of the teams were able to do it, all kinds of actions that they are interested in on the same platform itself. So it's a general purpose platform. Anyone who is interested in different kinds of use cases, right from streaming analytics to inference to just a simple event-driven application development, you should be able to do it. And the second thing that I want to highlight is, like already Derek mentioned, anyone can use any language that they are interested, and also you can see the auto-scaling capabilities, right? Within this pipeline itself, let me try to zoom in and then touch upon a few things. You can see the pod counts for each of these sources. Like you have 4 pods here, and if you look at the other steps, like 2 pods. So even during our conversation itself, if that based on the events that are flowing into the platform, each of these steps automatically scale, and there is nothing as a developer or as an engineer need to worry about. So all you have to focus on is your processing logic. Rest of the connectivity to different sources, scaling, all of that is taken care by the platform in itself. So that is the biggest advantage as NemaFlow would provide. So moving on to the last slide. It's basically want to quickly share about some of the use cases, how and where the product is being used as of today. I've just highlighted some of the companies like that are actually using it from the open source, but there are a lot more who are using it. We use it for a lot of inference, anomaly detection, and different use cases within into it. And the second one is like around digital signal processing. This is a very cool one. It's being used by B Cubed Engineering. They are into defense. Basically, what they do is they deploy all of these NemaFlow pipelines on edge devices, which are cut off from the internet completely. They don't have access to any kind of internet, and they process radio signals real time. So that is their use case. And if you think about digital signal processing, the teams are more interested in like Python, C++, that kind of an ecosystem vis-a-vis with like a Java or any of those. So they were able to use it quickly, and they were able to write multiple different kinds of sources like ZMQ and whatnot for their use case. And Lockheed, they actually use it for like processing some of their IoT sensor data and all of that. And then lastly, Atlan, they use it for data movement. It's a very cool startup if you would want to check it out. So across the board, if you look at all of these use cases, you can cover right from like stream processing use cases to inference use cases to data movement use cases across the board. So one platform doing all of that is what NemaFlow is all about. And you can find the GitHub repository. Would love to have you all start our project. It's completely open source. If anyone is interested in trying it out, would be happy to have a conversation after this. So absolutely. Thank you. Thanks a lot. It was a pleasure learning about, yeah.
Mentioned about the ISP or whatever interstate buffers which are there, and those have a back pressure that goes all the way back to the producer thing versus Kafka as the durable storage. How do you deal with failure scenarios?
That's actually a very good question. So out of the box, what the platform is, as a platform, we don't know what to do with the events once we consume them, right? So we keep on trying it as long as we can. And after that, but at the same time, we provide you the flexibility to drop the events, or probably you want to send it to some kind of dead letter queue and all of that. You should be able to configure, let's say, for example, instead of having one sink, maybe you can have another sink, which is like a dead letter queue, and then you can send all of your events there. So some of the use cases that we have it into it is, let's say, for example, you're writing to a database. Sometimes database do have like maintenance windows and all of that. So in that context, what would you want to do is, let's say, for example, if the DB is down, the back pressure will go all the way to your left and will actually stop consuming from Kafka. If that is the intention, that's great. But if at the same time, sometimes they don't want to stop processing, they want to send it to a dead letter queue, we provide that flexibility to have a fallback sink at the sink level, and then you can drop all of your events to that. And another cool part is you can actually use that sink as a source into the same pipeline and then reprocess those events whenever you're interested in. So because we support like multiple sources in the same pipeline, you can use the same sink as a source and then reprocess the events.
Just something to add, NemaFlow, I think Sri mentioned there's a data queue for a sink, right? That's what we call a fallback sink. So if it's not a sink, let's say for a regular user function, if you want to do some different processing logic for the data, the different downstream, there's a very interesting feature called conditional forwarding in NemaFlow that you can actually give each message you process a tag, and then based on the tag you give, you want to forward the message to different downstreams. Now, that's like that's like you can do, for example, you have some message, you cannot process this moment. You can give a tag, hey, give whatever tag you want to give, and then you can configure things like forward the message to some particular place.
So for example, here, you can see that from post-processing, we are actually sending all of the events to 3 different vertices next, but you can actually do a conditional forwarding where you can tag each of the events saying that, hey, send it only to the trainer if it's only required, send it to wavefront transformer or like to the Kafka transformer. Like you can tag it and then send to any vertex that you're interested in.
As a platform, we don't lose any message. If you actually process message with some failure, we're gonna keep retrying. We're not dropping any message for it.
All right, any other questions? Okay, we'll take one more.
Hi, this is like a really cool project. So I had like a bunch of questions, but one of them was like, if you have an event coming in, let's say you want like to do processing using an LLM. So use cases like LLMs can potentially benefit from batching across different requests. So like in that case, does the user offload the batching or the computation to some other microservice which does the batching for you, or does it parallelize across your pipeline? And my other question was that, is this ecosystem meant only for like streaming in general, or can you just use it as a general purpose event-driven system wherein you want to like orchestrate workflows using these event triggers so that when one pipeline finishes, you begin executing another pipeline based on some triggers or signals, kind of like Argo workflows or Maestro or whatever?
Got it. So to answer your first question around like, in generally in the context of LLMs, ideally you would want to buffer all of your events and then do act on those events as they come in, right? As a platform, we already have like interstep buffers in between. Let's say, for example, you can take a 3-step pipeline where you have event source, all the events coming in, and the second step is like inference, where you're just calling in an LM, and the third is like based on the results that you get, you are just writing it. Now, because we already have the buffers in between, we hold the events as long as we can. And after that, we act on those events as they like one after the other. So it's taken all of the capabilities that are available for you in order to buffer the data and then act on the data one after the other. And at the same time, if you want to really scale out, we will do it automatically based upon the processing rate. Let's say, for example, one of your vertex is just able to process like 2 events, but you have like 100 events available. Maybe you would want to scale up to 50. We will be able to do it, but again, there's resource constraints and all of that. You have resource quota constraints, but you can define like what is the maximum up to what you want to scale and all of that. But scaling will be done automatically based on the throughput. So that's one question. And the second is you can actually use it for a generic event-driven application development. So for example, like there is one from the community. What they actually do is they process a lot of map data. It's basically what they do is they just send out a trigger. They pull the data from S3. They do a processing on that data, do a bunch of like pre-processing such that it can be downloaded by real-time navigation systems. So you can actually use it as event-driven workflow as well. So those are some of the use cases that even at Intuit, we actually use it for.
For the demo, I saw that you guys were using gRPC. Is that universally adopted across your product? Or, I mean, can you switch around with what protocol you use?
Yeah, let me take that question. So the gRPC in the picture actually is used in each of the part of the vertex. So we're not doing gRPC communication between those vertices. So the way we use gRPC is like the way we support multiple language or language agnostic is like we are actually having multiple containers running for one pod, and for the platform code is running in one particular container, and then the communication between the platform code with the user defines code, let's say UDF or UD source and UD sync, we're using gRPC. And then we're using gRPC over Linux domain socket, which is much secure and much faster. That's why we use gRPC.
All right. Any other questions? Let's give them a round of applause.